Today we are talking Death Stranding and desire paths. More aptly, we're talking about networking and what enables this feature. So it's a feature I noticed straight away while playing, and I think I mentioned it, but I didn't want to talk about it too much because I needed some time to think about it and phrase it, mostly because I was worried about breaking NDAs and doing the right thing. So Death Stranding desire paths, what is this about? Well, basically on Death Stranding you got this huge ass map, you've got delivery points on this map, and then you've got a whole bunch of obstacles, right? How people navigate these obstacles is unique, but people tend to go in roughly the same direction, right? So like if there's an obstacle here, they'll tend to go around, and then some people will tend to go around like that. Now, in the real world, we call these desire paths. The classic reason for the desire path in design, because it's a concept in both physical architecture design and like game design, is say you got a crossroads like this, and people are walking along the pavement here, and they want to turn this way. If there's no building or anything here, quite often they'll sort of cut across here. And that basically means in your grass you get this worn out thing and it looks really shitty. And one of the ways to sort of resolve this is basically you take your lovely grass and you put in little pebbles, or you put in a gravel path, or you put in something roughly matching the direction people naturally want to go, the desire they've expressed to travel, and that encourages people to follow that, because it turns out that if there is a path that looks like it's semi-formal or looks like others have used it, partly through like social natural selection and stuff, because other humans or other animals have walked this way and survived, therefore it's a good path. So there's an evolutionary aspect to it. So you can actually really strongly influence people's behavior with desire paths. So why are desire paths important to Death Stranding? Well, the problem that Death Stranding faces is it has a massive map. There's really interesting points with stuff on it, right? And there's some big landmarks like a river and all that jazz. But most of all this is white. It's nothing. It's boring. So players put down structures in these interactions, but players' interactions are these tiny little dots. And the game is all about finding other players. Now, if you didn't have these desire paths in the game, what would happen is, yes, you have a scanner that lets you sort of scan wider than your field of vision so you can see stuff, but people aren't going to always be actively scanning. And even the active scanner, if you're constantly using it, well, it's more of a sort of traditional frustrum than it is a circle. People are going to miss stuff, right? And the world's going to feel empty. Whereas if I'm walking along and there is like an open landscape in front of me, so I mean, here's the classic one, right? There is this wonderful, let's say that there's the Seattle Space Needle I'm traveling to, and here's me, right? And I've got to travel there, and there's some crap in the way. Now, at the moment, if I gave, no spoilers here, no spoilers at all, we're just talking about desire paths and how this infects networking. So now if I gave this blank piece of paper, I printed it out, and I asked a whole bunch of people to draw the route to this location, a lot of people will draw something roughly similar, but it'll be like some people draw that, some people draw that, some people draw that, some people draw that. There'll be a lot of different lines, right? And if you overlay all these people's lines, there'll be a general sort of trend, that sort of a fat squiggle like that sort of comes up, but they won't perfectly line up, right? But now if you take that multiple people's walking path that they drew in on this piece of paper and you sort of laid it on top of each other, you'd get this heat map. And this is what the game does, and it gets these heat maps, and then it says, well, this sorry, just undo that. Then it says, you know, this here is a path, and this here is a path. Now, if I said to people, if I showed these as paths or as rough worn trails, and I said to people, draw the direction you would take, most people will draw pretty close to the line. Yeah, people wander slightly off the line, but it'll reinforce that. And over time, you'll go from sort of these fat squiggles like this, right? Because you've got a bounded point here and a bounded point here. But over time, it would narrow down till eventually you get sort of like that. And because of that, this huge wide open map, which is mostly empty space, yes, there's these areas that people tend not to go as much, which is interesting in of itself, but most people traveling from A to B will see a lot of the similar sites and are likely to come across ladders and things placed by the players. So from a design point of view, this is really awesome and this is really great. So here's the cool part. So this is the part I was trying to be careful about, and I needed some time to think about it. So Sony is this big company, right? And just full disclosure, I work for Sony. I'm not going to talk about anything super secret here, so don't worry. And inside of Sony, there is PlayStation. And inside of PlayStation, there is an entity called Worldwide Studios. This is first-party studios. So this is people like Naughty Dog, Horizon, Media Molecule. Everyone's kind of in this family. But also in this family is a thing called OTG and Game Analytics. And this is my old department, OTG, which is Online Technology Group, right? If you look in credits, you'll see us, like, we're there. This is not, as I say, a huge secret or whatever. And then Kojima is not part of Worldwide Studios, but worked with Worldwide Studios to do this. So they're not owned by Sony PlayStation, but they worked very closely. So like Horizon gave the engine, the Decima engine, OTG provided the server infrastructure, Game Analytics provided analytics support, and then there's a whole bunch of Sony and PlayStation stuff that kicks in to help out with that, and Worldwide Studios, like marketing teams and stuff, all helped out with that launch. So why is this relevant, you ask? Well, because I joined OTG 5-6 years ago, around about 5-6 years ago. I think it's closer to 5 than 6. Anyway, and I was asked to look into basically getting people to use platform features, getting people to innovate in networking. And I did a whole bunch of inside the box talks, internal talks that only were inside of Sony, where I could talk about more risque stuff. I did some external talks and also worked with a team called Strategic Content, which used to be run by Shahid, and this is actually very similar to what Shoes are going off to do. So this was like our indie initiative, a lot of small things. So that's not part of Worldwide Studios, but it was an important thing, and I worked with them a lot because, and one of the partnerships that came up with that, for instance, was Loot Rascals, one of the ones that got published, and one of the ones that I actually helped out with quite a bit. And they used some OTG tech and stuff. So that was from a London-based developer called Ricky Haggett. And a whole bunch of other people, not just one person. But anyway, so while I'm doing all these talks, one of the talks I'm doing around this time is at GDC Europe, and it's called Stop, Copy, Paste, and Innovate. I do a bunch of other talks around this time, and yeah, indeed, I do a bunch of other talks around this time. Stop, Copy, Paste, Innovate was at GDC Europe. I believe the slides are online and some of the talks online. But around this time, I'm talking about a bunch of cool features, and one of the features I'm banging my drum on about, there's a bunch of them, banging my drum on about, like multiple ways to boot the game. I'm trying to kill game lobbies. Lobbies were a big part of my thing. But then another thing I was talking about was I was talking about exactly this feature, this desire paths heat maps feature. And actually, internally, I think this is safe to say, it's totally chill. It's a very long out game. I was speaking to the Horizon team about potentially using an Horizon. Remember, Horizon helped with Kojima. Now, it's important at this point to mention that, you know, like, calculus was developed separately in multiple places. This is not fucking rocket science. This is not calculus. So it's totally possible that someone on the Kojima team just came up with this without thing. But the important thing is, when I do these talks and these ideas, I really want people to steal them, and I want people to use them as much as possible, and I hope everyone steals Kojima's heat map design and uses it as a template to bring off into their own stuff, because it's a fantastic fucking idea. So why is this such a powerful concept? Why are desire paths and heat maps such a powerful concept? Well, because networking's expensive, right? And there is this jokey network cost equation that I talk about. Now, this equation, by the way, is not an actual equation. It's just like a thumbsuck equation. It gives people a sense of how expensive a networking feature is, right? So the cost of a networking feature is equal to the number of players, right, times the number of data divided by the speed, right? So this is a very simple version of it. There's a more complicated version, and I'm going to show you a second version of it in a sec. But basically, the cost of a network feature, the more data you want to send to it multiplies out, the more players involved in the sending multiplies out, and any delay you can introduce to the system helps. So the classic one for this, by the way, is, let's say we have two players in a network environment, and there is a shiny bit of loot between them, right? Now, if both players push X and they want to pick it up, immediately there's this network contention issue where we've got to decide which of these two players gets this thing, right? Now, if the pickup animation is really, really fast, then the speed part of this becomes really hard. Now, the data is very small, but the speed part's tough. But now, if, for instance, we have to play an animation, the animation doesn't have to be long. The animation can be like 100 milliseconds, right, which is a tenth of a second. That gives us enough time to negotiate who should get this thing, because we have to be 100% certain we can't backtrack on who gets this thing. Now, in reality, you're probably playing like a 500 milliseconds or a second animation of picking something up, or you're doing like a progress loading bar, because within 10% of the animation, or within 10% of the loading bar, you've kind of decided, so this is it. Basically, you've got to do network contention resolution, right? Because this person may have pushed it at X, and this person may have pushed it 50 milliseconds before this person pushed it, right? And you can't allow their slight difference in latency, because let's say this person's got like a 200 millisecond ping and this person's got a 50 millisecond ping. If you don't put in this kind of buffer design, that means that in theory this person could steal loot a lot more than this person, right? So by introducing latency into the system, so delay in the system, you can lower the cost of the system when you're building it and implementing it, right? So that is the big problem on this. The classic example, and the most simple example to resolve this, I'm not going to do a full networking talk right now, I'm trying to focus on Death Stranding desire paths, is something called stop lock, or lockstep, where basically you have a logic frame. This is the simplest because it's the most reliable. You have a logic frame that is, say, 500 milliseconds, right? Now, bear in mind, a 60 millisecond game, each frame that you render is something like 33 milliseconds, if I recall. My math's probably off on that. I'm just going off the top of my head and I'm forgetting. But it's 1/60th of a second. Do the math. So what you do for your networking step is you say for every 500 milliseconds or every second, you can log your actions. We will resolve everything. We will not move forward to the next logical frame until we have what everyone did in that frame and we all agree on it. And then we'll move on to the next frame. And what this means, and this is one of the oldest forms of networking sync, is that if one player drops out of the connection or one player has faulty issues, then all the players... there we go, that's what I meant. 0.33 is 30 frames a second. That's why I was thinking of that. But one of the things is that if a player lags for some reason, the game effectively locks up for everyone. And this was the classic situation where like a Quake player is running in place. So how do we solve this? Well, in the modern world with the cost equation, we actually lie to you a lot. We do things like hitbox prediction and all these kind of things. And so the cost equation's actually evolved a bit to, and I've got a much more complicated version of this, but it actually works out to cost players times data over speed, right, raised to the power of players who know. Okay, I know my writing is terrible. Players who know. Now, why is that important? Because basically, in the situation where those two players are arguing over a piece of loot, the inclination is this is a 32-player game, right? There's 32 players in a session, or let's say this is a battle royale and there's 100 players in the session. Do 100 players need to know? I'm using a Wacom, yes. Do 100 players need to know who got this first? No. There's only 2 players who care at this speed. Now, all of the other players, so these 2 players give a shit about this loot crate in, say, 100 millisecond time frame, right? But do the other 100 players do? No, they can get as much as like a 3-second latency, right? They can even go up to like a 1-minute latency, right? I don't have to verify straight away that someone has picked up a gun, for example. So, desire paths, why are they really cool? Because they're what we call a highly latent system. When you've got point A and you've got point B, and you've got, I'm going to say conservatively, 100,000 people walking between A and B, you don't want to have 100,000 people talking to each other. So instead what you do is you take every person's journey, right, and you log it to a telemetry server or a game server. Right, you can do it either way. And then on this server, what it does is it buckets up this data in all kinds of ways, right? So it's like, these are the people that finished this mission using, these are the people that finished this mission using 1 health pack, right? Or in the case of the map, you bucket it into a grid, right? So you're not storing every exact point, but you're bucketing it into a grid, and you say, okay, well now we know that this square here actually had 100 people walk through it in the last while, but this square here only had 2, right? And so then you pixelize the map, if you think about it like that way, and you can start expressing out these desire paths. Now the joy is your communication to this telemetry server can be really, really fast, right? It can be like 100 milliseconds. The compilation of this, right, the latency of the path data, this can be as much as 1 hour, right? We don't actually care, like this data doesn't have to be super fresh. And so from a networking point of view, we can sync up this heat map very infrequently, and it's a very cheap system to implement. And I actually have a version of this that an indie can implement using system storage in Steam or PlayStation. So you can even do this without having a game server. The atomicity of the interactions vertex is very excited about this in the background. The atomicity of this is very interesting and very easy. And if anyone's more interested in the technical, how would you implement this, it's not hard, and I can point you at some more details. Before we move off of it, yes, Vertex? Yeah. Okay, sorry, my cat's very excited. To people who are around symptoms, yes, you could definitely bucket into like these paths are more efficient or whatever. You probably wouldn't want to do that though. You could also, yeah, Vertex and Pixel, my cats. You could also limit it to these are late game paths, these are early game paths, or whatever. But this heat map strategy, or this geo bucketing, I call it, is really interesting because now, for instance, one of the things is pretty much all modern games have these kind of analytics. But let's say you have a shooter, right? And you start off with this really clean, pristine map, okay? Now, if over time with your telemetry, you logged wherever people died, and you logged like bullet holes and shell casings and stuff like that, like you can layer up a few things, right? So you can layer up like deaths, hits, so that's like bullet holes. I'm just going to draw a little hole. There we go. You get what I mean? Yeah, so blood splat. Yeah, deaths, hits, and movement, right? So this is like one thing. Now this is really interesting, right? Because for instance, if you're playing Counter-Strike or you're playing a competitive shooter, people very quickly learn like, oh, taking this path is really stupid because everyone dies there, right? Like that's a very exposed route, okay? But this is institutionalized knowledge that's in people's heads. And as the meta moves, because like no one ever goes there, then people start never aiming there because no one ever goes there. So this now becomes a safe spot because no one aims there. And so there's like a moving meta and evolving meta. So you want to sort of timestamp this data. But now if you were doing a shooter and you were to use this heat map style information and you were to expose this, right? And all you do is you basically generate a heat map and the locations and whatnot. And then in all of your textures, you basically have a shader that goes from like 0 to 1. And like for the movement, it would be like you'd start like showing footprints and wear patterns or whatever. For the movement, you might also encode directionality, which FYI is not very hard because you don't have to encode. The first instinct people would be like, oh, you have to encode like a full sort of vector. It's like, no, you can encode 0 to 1, and then you can encode a second 0 to 1, and the second 0 to 1 is literally just a rotation representing 2 pi. So you can actually encode how worn and the directionality into 2 floats very easily. And then your shaders can basically express all this. Likewise, you can have blood spats on the map and stuff. And so, yes, so this is what we're talking about. This is the desire paths in the game. So in Death Stranding, the shader is the grass gets worn away into dirt paths. And it's a very simple shader that implements that. But likewise, they can do the same thing with rocks and all this stuff. So this is the feature we're talking about, and this is what I want everyone to steal. And as I say, like, this is why I talked about this feature and a whole bunch of other features around this, and it's inspired me that I'm actually going to do a few more of the old topics. I'm going to pull out them as individual, and I'm going to do these morning talks where I'm just going to go through one individual concept in those ideas, because I normally am like, oh, here's a talk where I'm going to briefly talk about 100 concepts kind of thing, and now I'm like, okay, actually no, I'm going to dive into each one of these. So yeah, that's Death Stranding Desire Paths. It's a very, very simple idea where we go and we sort of help the map grow. So yeah, that is that. And with that, before we stop, is there any questions? So this is the Q&A segment, so live people get to ask me any questions about this concept, and then we're going to wrap up the YouTube recording in a bit. This is on Twitch if you're watching on YouTube. So to answer your questions, yes, this is the desire paths from Death Stranding, Vertex and Pixel are my cats' names. With the data, the desire path stuff, you can definitely bucket it. So for example, if your game had Class characters, you might want to bucket in between like people playing this Overwatch character run this way and people playing this Overwatch character run this way. That's a very common cohort analysis that we do in analytics stuff. But yeah, you want to keep it simple if you're visualizing it into the game, because you want to make sure you have enough data. Yeah, so no, it's all Death Stranding related. How would you best split people that go from A to B? Could the implementation be... so very simply, what you do is in your telemetry, you would have like a marker that this person's last visit was A, and then when they arrive at a destination, i.e. you're setting this to their last is now B, right? You can take that frame of data and you can say that is the last journey they did. And this sort of time slicing of data is quite frequent. So for example, a common way you slice this data is whenever you spawn someone and whenever they die, so that is their current life. Or the most common version is whenever someone joins a game and leaves a game, and we call that a session. So there's a lot of ways you cut up and bucket this data. Basically what you do is you have a whole bunch of tables that have this individual data, and then you have services that aggregate it into buckets, and then some services operate on those buckets to make even more buckets and complex things. So as few things as possible, try operate on this core chunk of data, because it's really there's a lot of it and there's a lot of stuff to chunk through. So as much as possible you have sort of sub steps chunking things into little buckets, and then you have other things chunking into buckets, and then you can have like this thing operates on this and this and does this or whatever. So that's generally the strategy for it. There's whole talks on this concept, but yeah, this is very easy to do, and it just requires that you have the stuff in place. And the big thing with all these kind of operations is you've got to think about how they add up, right? Because you don't ever want to, if you've got a whole bunch of paths, you don't want to be going, well, compare this path to this path. What you want to be doing is you want to be doing operations where the order of operations doesn't matter. So adding things, multiplying things is always good. When I say subtracting things, I mean adding things, because the subtraction, so A minus B is not equal to B minus A, right? So that's why subtraction doesn't work. But addition can add negative values, because then it's commutative, much like with division and stuff. How roads work in Death Stranding. Roads themselves are just a built-up thing, and I'm not talking any NDA stuff here, because full disclosure on NDA stuff, I did not work on any Death Stranding stuff. I did not consult on Death Stranding at all. I was there when OTG started the work on Death Stranding, and Martin Shenton's team did a lot of that work and support. And if you go through the credits, you'll see all the names of the people who contributed to that. And you'll notice my name's not on there. So yeah, I left for Media Molecule before the work got into any serious earnest. But I doubt I would have done much more than like consultancy anyway. Okay, with that, I think I'm going to use that as a moment to stop. So ta-ta monsters, and I will see you on Friday, tomorrow.